right, everybody who's going through 1.2 arithmetic series for grade 11. So what we're going to do today is we're actually going to move from learning about arithmetic sequence to moving into arithmetic series. So you can follow along in your book, and just whenever you have a little blank space here, you can write some stuff in. But we're going to be writing a couple of formulas down that you should be adding to a formula sheet that you should start. So the very first thing I want you to do is get out a sheet of paper and title it formula sheet. Okay, and the first thing that you're going to put on your formula sheet was from our arithmetic sequences, which is what we were doing in 1.1. So arithmetic sequences, an example of that would be 2, 4, 6, 8, and so on and so forth. So that's when something's going up by the same amount each time. It's just listed. Okay? The general term for that is Tn equals T1 plus the common difference times n minus 1. And D was how much it went up by. N was what number you were going to. So if you were looking at the 20th term, then n would be 20. And T1 was the very first term. Now we're looking at something called an arithmetic series. So this should be on your formula sheet as well. The only difference between an arithmetic sequence and an arithmetic series is that in a series, it's actually summing all of the terms together. So you're actually adding them all together, which means instead of writing 2, 4, 6, 8, you'd be writing 2 plus 4 plus 6 plus 8, etc. So it's still going up by the exact same amount. It's just that it's now being added together, which is not really very much different. The formulas that we're going to actually add to our sheet right now have to do with arithmetic series and actually summing the arithmetic series. So that means when I'm summing something, I'm adding all of the terms together. And there are two options to use for that. So this first one says the sum of the nth term, so I don't know what term I'm talking about yet, so the sum of all the terms up to a certain point is equal to n times t1 plus tn, all in brackets, divided by 2. And the second one that I could use, if I didn't have enough information for the first, would be Sn, so the sum of a whole bunch of terms, however many I want, is equal to n times 2 times the first term, plus the difference times n minus 1, and that's all over 2 again. And you can find those on page 16 of your textbook. You do need to have this separate formula sheet ready to go so that you can just quickly refer back to it whenever you need it. So, as I said before, an arithmetic series just sums up a bunch of the terms. So instead of just looking at what is the 20th term, now we're actually asking questions like, if I added all of the first 20 terms together, what would that end up equaling? And that's what the arithmetic series is going to help us find. So what I'm going to do is I'm now going to move on to the first example, and this example is on page 16 of your book. So when you go through it, it says it would like you to determine the sum of the first 6 terms of this arithmetic series. So what I'm going to do is I'm going to write down the information that I know. So I want to find the sum of the first 6 terms. I know what those terms are. I know that they go up or down by a certain amount. And so I'm going to decide whether I should use my first formula or my second formula. So if I take a look at my first formula, I'm going to ask myself, since this is the simplest formula, I'm going to try to use it first. So do I have all of the information I need in order to use this? So, do I know which ones I'm trying to sum? Yes, I do. I know I'm trying to sum the first 6 terms. Do I then know n? Do I know how many terms I'm trying to sum? Yes, I do. There's 6 of them. Do I know the first term? Well, yes, I do, because the arithmetic series is actually written for me right here. So it's a series, so there's actually no comma. And this is written in example 1, so you can check it out yourself. And onwards and blah, blah, blah. Okay, so I actually do know the first term, and that's negative 75. Do I actually know Tn, which would actually be T6 in this case? Do I know the sixth term? Well, yes, I do, because I'm lucky enough that they gave me all of them. So 1, 2, 3, 4, 5, 6. The sixth term is negative 45. And I keep the negative in front of it, because whatever's in front of it goes with it. So now I'm basically just doing bed maths. Now I've got 6 times negative 75 minus 45. Or if you want to read it like 6 times negative 75 plus negative 45, I end up with, let's see, negative 120 here. And that's all over 2. If I go 6 times negative 120, I end up with negative 720 all divided by 2. And in the end, I end up with negative 360. So what that's doing is telling me that if I added the first 6 terms in this arithmetic series, what I would get is equal to negative 360. So my plan whenever I look at any of these questions is to determine what information do I have, and then from there, what formula can I use with that information? What's the easiest way to do that? Okay, so now I'm going to go on to example 2. I'm hoping that you will be able to try to check your understanding on that page on your own. So on page 16, number 1, or check your understanding 1 should be done. Give that one a try. So just put it aside. I'm going to go through example 2 right now. Example 2 is on page 17. And what it says is that an arithmetic series has T1 equal to 5.5. And D, so the common difference of negative 2.5. That means it goes down each time 2.5. What I would like to do here is determine what S of 40 is. So the S of 40 actually means if I added up the first 40 terms of this arithmetic series, what would I get? So now I need to determine what information do I actually have. So I have T1, I have D. So if I think back to my original formula, my simplest one that I have, I'm going to see if I have enough information. First off, do I have N? Yes, I do. I'm looking for S40, so I know that N equals 40. Do I have the 40th term, though? So I'm looking for T40 here. Do I actually know what that is? No, I have no clue. I only know the very first term, and that's it. So I actually have 2 unknowns here. I'm trying to find the sum, and I also don't have the term, so I cannot use that first formula. What I can use, though, is the second formula. So if I write that out, that's S of N is equal to N times 2T1, and you can go back to your formula sheet to remind yourself of this, plus D times N minus 1 all over 2. Let's check things out. Do I have what I need? So S of 40 is what I'm looking for. So do I have N? Yes, I do. It's 40. Do I have T1? Yes, I do. It's right there. It's 5.5. Do I have D? Yes, I do. It's negative 2.5. Do I have N? Again, yes, I do. So I have all of the information I need in order to figure out what S of 40 is. So I'm going to do that now. N is going to equal 40. I know 2 times the very first term, so 2 times 5.5 is what's going to go there. I know D is negative 2.5, so instead of writing plus minus 2.5, I'm just going to go a shortcut here and do minus 2.5. I know N was 40 again, so 40 minus 1, and then close the bracket. The main thing to remember when you're doing questions of this type is to keep everything nice and organized and keep track of where you are. Otherwise, you'll really be hooped. So you've got the sum of 40 I'm going to do everything in the brackets first. So I've got 2 times 5.5 is 11. I've got 40 minus 1 is 39. I've got 2.5 times 39, which I can put into my calculator because I'm lazy and I'm really tired at the end of the day. And that's going to end up equaling negative 97.5. And that's all over 2. Okay, so then I do the next part, which is to actually do the subtraction in the bracket, and that is going to be ending up being negative 86.5 all over 2. Then I've got 40 times negative 86.5, so that ends up being negative 3460 over 2. And then I'm going to divide that, and I'm going to end up with negative 1730, which means if I sum up the first 40 terms of this arithmetic series, I'm going to end up equaling negative 1,730. Okay, so there's a check your understanding on page 17 as well at the top, number 2, that you can try on your own right now as well. Alrighty, the last one I'm going to do as an example is not going to be, actually yes it is. I'm going to do example 3 for you, and then I'm going to allow you to try example 4 on your own. So example 3 is going to be the last one I'm doing, so make sure you pay close attention. So example 3 is on page 17 as well. And it says an arithmetic series has S20, so the sum of the first 20 terms is equal to 143 and 1/3. The common difference is equal to 1/3. And the 20th term is equal to 10 and 1/3. It wants you to figure out what the first 3 terms of the series is. So I know right off the bat which one I'm probably going to be able to use. And that is, I'm going to try and use this formula. Whenever I can, I'm going to try and use this formula because, frankly, it's simpler. So I'm going to go ahead and I'm going to try and figure out what I have and what I need. So do I have what S of 20 actually equals? Yes, I do. So that's good. Do I know what N is? Yes, it's going to be 20 because it's the sum of the first 20 terms. Do I know what T1 is? No, I don't, but that's okay because I'm actually trying to find what the first term of the series is. So that's okay for me to have a variable there. Do I know what the 20th term is? Yes, I do. It's sitting right there. So I do have all of the information I need in order to get started on this one. So the sum of the first 20 terms was 143 and 1/3. I know that N was equal to 20. I don't know what T1 is. That's what I'm trying to find. And I know that T of 20 is equal to 10 and 1/3. So I'm going to go ahead and put all that in. This is where strong algebra skills come into play. So that means now I need to use the distributive property, which means you might have learned this as feeding the chickens. You're actually spreading the seed to everybody in the brackets. And I'm going to rewrite that down here. So I've got 143 and 1/3 still hanging out on this side. I've got 20 times T1, which ends up being 20 T1. And I've got 20 times 10 and 1/3. So I've got 20 times 10 ends up giving me 200. And 20 times 1/3. So if you're doing this by hand, you could quickly just do this because 20 times 10 is 200. 20 times 1/3 is 20 over 3. And then how do I simplify 20 over 3? Well, 3 goes into 26 times, so I'm going to add that here. And then there's actually 2/3 left over. That's a quick way to do it. It's nice. You should be able to use fractions just fine now. And I'm going to assume that you can. All right, so first step is to get rid of this 2. So I'm going to multiply both sides by 2. That crosses out. I've got 2 times 143 and 1/3, which ends up as 286 and 2/3. You can check that out. I'm going to assume that you know how to do that. Now I'm going to do my algebra, which means I'm going to subtract. 206 2/3. Okay. Hang on one sec. Gotta fix that. Okay. Now, negative 206 2/3. That cancels out. And now what's happening is I've got my next one going. So I've got 286 2/3 minus 206 2/3 is equal to 20T1. So let's do that up here. So 286 2/3 minus 206 2/3 is 80. And that's equal to 20T1, which is from down here. Divide by 20, divide by 20, and I've got T1 equals 4. Now that's part of my question, but not the whole thing. The question actually asks you to please go and find the first 3 terms of the series. So I know if that's the first one, and the common difference is 1/3, I'm going to add 1/3 for the next one, add 1/3 for the next one. And then I've actually answered my question. So I know that was a lot of information. You can go back and rewatch some parts if you need to. What I would like you to do right now is to check your understanding number 3 on page 17. All right. I hope you have a great evening, and I hope that helped. See ya.